So what I want you to know is we basically have spinal nerves coming from the spinal cord, and it goes from neck to pelvis. So all of these nerves are involved in sensory input and motor output. If you want to move, you have these plexuses starting from the neck to the arm level to the lumbar to the sacral. There's a lot of these nerves that are bundled in branches. So the peripheral nervous system is everything outside of the CNS. That's all you got to know. Everybody's heard of the sciatic nerve. So you generally know the sections of the spinal cord, and that accumulation or groups of nerves are called plexuses. Since we go from cervical to sacral, it's like real estate: location, location, location. So, how do we know where something is hurting or where something is moving? Everything is based upon location, location, location. And we know what's happening from top to bottom. Everybody knows what a reflex is. You put your hand on a hot stove and you don't even think about it. A receptor tells you it's hot. Sensory neuron goes information to the CNS. The motor neuron moves the muscle. You don't have to think about anything. So this is an involuntary motor response. Motor meaning muscle movement. So if we look at the diagram of a stimulus, you put your hand on a tack, sensory input goes in through the bipolar neuron into an association neuron and then into the movement of the muscle. Uh, Sensation is relayed uh, on the white matter up into the brain. So take a good look at this and know the general definition of a reflex and its pathway. There are monosaptic reflexes where sensory neuron goes directly to the motor neuron. Stretch reflex, like tapping your patella, uh, muscle spindle sensory receptors that is constantly telling your spinal cord and brain and your ultimately your cerebral cortex and cerebellum about what's happening in muscles. So here's a simple reflex, the patellar reflex. You stretch this tendon here and you get a response. So this is a monosynaptic reflex. You also stretch the muscle. Polysynaptic reflex involves more than just a sensory neuron and a motor neuron. So here's the flexor reflex. Again, it involves a sensory neuron, an associative neuron, and a motor neuron. And if it takes care, your body takes care of the danger immediately and then sends information uh, through ascending pathways and descending pathways. So you will be aware of this. Reflexes are rapid, they buy time for planning, and more complex responses that are often more complex in their response. So, sensory pathways. So a sensory pathway is called afferent input. So you press on your cheek and you immediately have sensory receptors stimulated, and information on touch, pressure. Proprioception is the constant monitoring of the uh, state of contraction of muscles. Okay, so the first system is for sensory input. That's going to go up a ascending track, and there's first order, second order. So all this information that we are constantly not thinking about, the fact that we can sit in a chair, I can talk, and simple safety functions are taken care of first, but the information is always relayed to the sensory part of the brain. This is called a sensory homunculus, little man, and you can see that how much part of the sensory cortex is dedicated to the hand. Okay, there's face and so on. So basically, surviving down here, analyzing it, thinking what to do about it, and surviving. That's a good idea. So, motor pathways mean that these are efferent impulses leaving the central nervous system. So, in this case, we have the motor homunculus, and this is the primary motor cortex. Again, notice the pattern that the information, a lot of information is dedicated to activity of your arms and legs and face. Look at the hand. So information leaves, comes down from the cerebral hemispheres, and those are called descending tracks. So the whole point of this is to take care of muscular activity. And you can add, like the cerebellum is involved in coordinated learned activity. So this is the output to the muscles to control all the things that we do: walk, drive, sit. And then we'll get into the autonomic functions, which are things that we don't even think about. So read through this. Just know sensory in, motor out. Now, the autonomic nervous system. So, what is this all about? The automatic coordination of heart, digest, excretory, and reproductive functions. So, let's look at a picture here coming up. So, the autonomic nervous system is receiving information and taking care of not skeletal muscle. So that's the somatic nervous system. Everything else is automatically taken care of by the autonomic nervous system. So if we look at the arrangement of this system, all these destinations such as smooth muscle, glands, adipose tissue, cardiac muscle, that information is controlled and monitored by the autonomic nervous system. The somatic nervous system is taking care of muscle movement. So let's look at a picture here. So the sympathetic division originates in the thoracic and lumbar part of the spinal cord. So notice that there are preganglionic neurons and postganglionic neurons. So what happens here? So there's all this is called the sympathetic chain. These are the big difference between the autonomic and the somatic system is that you have preganglionic neurons versus ganglionic neurons. And you see right here, you have a little, it's hard to see, but you have the preganglionic neuron and the postganglionic neuron. So what does that mean? The heart tissue beats on its own. Everybody knows that the heart can slow down or the heart can speed up. The major control of cardio acceleration is from the sympathetic division. It's called fight or flight. So the automatic functioning of the body, everything from seeing to salivary glands, heart function, lung functions, digestive functions, reproductive functions, bladder functions are all taken care of automatically by this extensive autonomic nervous system in the sympathetic division. So taking care of danger, accelerating heartbeat, breathing more quickly, shutting down your digestive tract and urinary bladder when you need to take care of dealing with a dangerous situation. So again, the heart beats on its own. It has sympathetic control to accelerate it when need be. It can be slowed down by the parasympathetic system. Okay? Crises, alertness. So all of these are the effects of sympathetic activation. So this whole division is involved in dealing with crises, being alert, feeling of euphoria, a drug-free high, heart function, breathing function, and muscle tone. Then we have the parasympathetic division, which originates in the cervical portion of the brain and the sacral portion right here. So notice that there are preganglionic neurons and ganglionic neurons. So this whole parasympathetic system is called rest and digest. Notice that a lot of the cranial nerves are involved. I mentioned that vagus means to wonder. Notice what the vagus nerve does. Heart, lungs, liver, stomach, spleen, pancreas, small intestine, large intestine. So the vagus nerve is a cranial nerve number 10. All this automatic function, whether you're resting and digesting or responding to a crisis for the sympathetic system. So the effects of the parasympathetic system: relaxation, processing of food, absorbing energy, and so on. So the sympathetic division helps monitor and control gut functions and muscle function, reaches only the visceral structures using the cranial nerves. And I just mentioned how the vagus is an extensive nerve with many, many, many destinations. Many organs have dual innervation. They have both sympathetic connections and parasympathetic connections and their opposite effects. We're not going to worry about age-related changes. I don't want to talk about that. And that's it. So let's go back to the stop recording.